Hi, this is Ziping. I'm one of the group members with Yan Kim and Wimin. This is supposed to be a backup video file which shows a working prototype. For this prototype, it's slightly different, as in the algorithms used is different from Yan Kim's one. For this case, the threshold algorithm that I use is known as Otsu's thresholding, OTSU. This is being used in one of the MATLAB functions known as grayscale. So you can be sure that it has a background lah, okay? Then regarding centroid finding is basically the same, and distance measurement is more or less the same as Yan Kim's one. The video format is also different. As in, I'm using something that is faster in frame rate, because instead of capturing the original 1280 by 1024 pixels, I set the capture rate to be at 640 by 480. So when it captures less pixels, the refresh rate is faster. So you may see that the image is much more smoother lah. But the trade-off is that the captured resolution is lesser than what Yan Kim's implementation is. But since we are displaying on the LCM module, the LCM module is 320 by 240, so this wouldn't matter lah. Now you're looking at the experimental setup that I have at home. We have a fluorescent lamp which gives a very strong illumination. One of the problems that we met is that if the illumination isn't that great, there will be shadowy areas such as at this boundary of the paper, or when there are creases, or when there are grooves. So these artifacts will be picked up by the thresholder, which will show them as some grainy parts. So you might want to take note of that. This is our image. It's a small square pixel printed on the wall. It's not on the wall, it's printed on the paper that's fixed onto the wall. And as for the distance, we drew a few lines from 1 cm up to 27 cm. And the distance will be determined from where we place the webcam. Like if you want the webcam to be at a distance of 17, so you have just to make sure that the webcam lies in the plane of the 17 cm. We didn't make it smaller because the resolution of this webcam in terms of the distance resolution isn't that great, because of the jitter that is being introduced by the image from the CMOS sensor. I've just downloaded my SOF file into the board, so let us start. Okay, so we raise the camera so that it has a view with the square, so it's a bit hard to adjust. Okay, so let me give you a brief overview of the pin assignment. So S00 is used to control exposure. So 1 is a positive 1 and 0 means 0. And SW10 controls whether you are looking at the real image, as in image directly fit into the CMOS sensor, or the thresholder image. And SW11 controls the crosshair, whether you want to display it in a thresholded mode or not. And SW12 controls whether you want to look at the image from CMOS sensor 1 or sensor 2. And finally, for the 7-segment display, the 2 digits here represent the distance from the image to the CMOS sensor in centimeters, and the rest are zeroed out, because basically any distance beyond 50 cm cannot be resolved finally, because the centroid will more or less merge together The very first distance that we start measuring from will be more or less 8 cm and beyond, because any distance at 8 cm or less cannot be captured fully by this CMOS camera. As you can see, if I place it at the 8 cm, the square, if I position such that one of the CMOS camera has the square focus at its extreme left, the other CMOS sensor will more yes, this image will be at the extreme right of the other CMOS sensor. So anywhere closer, it will cause these two images to fall out of range on either or the both sensor. So this is at 9 cm, 9, and if you were to shift that slightly beyond 10, be at 10 cm, 10, and if you were to shift further, 11, and it will be at 11, 12, 12, 13, 13, 14, 14, 15, 15, 16, yeah, overshoot a bit. So we position it maybe to the middle, 16, 16, 17, 18, 19, 20, 21, a bit of jitter, 22, 23, 23, 24. So it somehow overshoot by 1 cm after 20 cm. 23, 24, is this 24? Bad handwriting. 24, it registers at 25. 25, it registers at 26. 26, it registers at 27. So there's some kind of error involved here. So finally, 27, we get 28.